Hello everyone, welcome back to another video in our Module 2.1 series, Databases. In this video, we will be learning about the following materials. Let's start off with terms that you should be familiar with. A database is an organized collection of data. This is where data is stored for processing and retrieval. A database is similar to a spreadsheet in the sense that a spreadsheet also holds your data, but a spreadsheet is not a database. Keep that in mind. A spreadsheet or Google Sheets or Microsoft Excel, they are spreadsheets, they are not a database. A database management system or DBMS is a group of programs that manipulate the database. DBMS is the interface between databases and applications. Examples of DBMS include MongoDB, PHPMyAdmin, PostgreSQL, among others. Again, your DBMS, you use it to interact with your database. And last is Database Administrator or DBA. This is a person and is an IS professional who is skilled in the structure of the database. So the DBA directs activities related to the database. Let's move on to the hierarchy of data. Recall to our video on hardware where digital data is kept in bits. So all digital data is in the form of ones and zeros. 8 bits make a byte, so those are bytes, kilobytes, gigabytes, and megabytes, and so on. So let's just move on. Next, we have characters. Characters such as your letters, numbers, special characters such as period, comma, question mark, these are all considered characters. These characters are all made by a bunch of bytes. So, characters are made of bytes, and once you have a set of characters, you can make out information. As described over here, characters are the basic building block of information. So if you have a bunch of characters, let's say SAMSUNG, right, Samsung, they make up a full word, so characters make up your information. Next are your fields and your records. Fields and records are in the same hierarchy. I want you to imagine a table, like in a spreadsheet with rows and columns, right? Whenever you open up Microsoft Excel or Google Sheets, you are faced with a bunch of rows and a bunch of columns. When you write down new entries in your spreadsheet, you write down entries per row, correct? And in the columns are data about that row. Sort of something like this. Here, in the column areas, you have your student ID, your last name, your first name, and your birth date. And in the rows, and in your rows, you have your data about what's ever written. All the data that are in the same row, right, like 54001, Bansa, Gothboy, and the birth date, they're all related to each other. So, you know that student 54555, this student over here, is related to Foxtrot's Vergara and has this birth date. This is your standard table. So again, fields are your columns, okay, and records are your rows. Now, being familiar with the rows and columns of a table, fields are your columns and records are your rows. Your field, your field or column or other terms include your dimensions, your features. There are just a bunch of names that you can mix up with each other, okay? So field, dimension, features, or what we want to call a column, right? Basically, it's a column. They are names, combinations of characters that describe an aspect of a business, object, or activity. So this is your column. Next up, you have your record or row, or sometimes you also call it an entity. Okay, so record, row, or entity. It is a collection of related data fields. So in this example, again, these are your columns, these are your features, and these are your records. They are in records, they are all related to each other, right? If they are on the same row, they're all related to each other. Next, we have a file. A file is a collection of records. So what do we call a collection of records? For example, this is a collection of records, right? We have a lot of records here. Then we call that a table. A file is a table. And last is a database. A database is a collection of integrated and related files or tables. So a database is a collection of many tables. I hope that is clear. Next, why do organizations collect data in the first place? Imagine entering a mall. Before you enter the mall, there is a guard that checks your bag, right? In the Philippines, they check your bag and has this clicker type of thing that counts the foot traffic that enters the mall. I want you to pause and think for a moment about why they do this. Or I'll give you another example. Try thinking about why do you need to register your car if ever you have a vehicle or other vehicles. You have to go to LTO and make up a new original receipt or a new registration, right? You need to register your license plate, your address, your registration, and any whatever other details that they need. Why do you think they do this? So in the first case, right, it is for at least for the ones in the malls, like for SM and Robinsons. Sorry, they use it to keep track of their performance, or at least how many people are actually going into their mall. Um, and for example, there are a lot of people coming in on weekends rather than on weekdays, so they can keep track of how much security they need to prepare, the lights, the air conditioning, how cold should it be, stuff like that, right? But for the second one, the LTO example, it is more for security reasons, especially if a vehicle is involved in a crime or an accident, right? They can directly ID the vehicle to who it is registered under, the offense, the place, the city, and other details. It is to focus on keeping other drivers safe as well. Okay, moving on. That is why organizations collect data. Um, and this is why we need to study databases. Data management and modeling are key aspects of organizing data and information. A well designed, well managed database is a valuable tool in supporting decision making. Again, our goal as MIS personnel is to turn data into valuable information. And with the help of databases, we are able to achieve this because the databases are the ones that hold our data. That is where we will get, that is where we store the data to turn into information. Okay, let's move on. So I have already talked about this in our previous slide, right? The hierarchy of data. Records are your rows of the table, fields are your columns of the table. And we have our table. So let's just move over from this. I want to focus more on this slide. Okay, this is a different table. Um, I want to focus this key field over here. This is what we call the primary key. Okay, this key field or primary key. The primary key is the field or column that makes your record unique. So it makes everything in this record unique because of this column over here, your primary key. No other record on this table, if for example you have a million rows or 1,000 rows, it doesn't matter. No other record on this table could have the same primary key. The primary key is also sometimes called your unique ID. So for example, your primary key here is 1011. That can never be repeated anywhere on this table again as a primary key. Okay, so this 1011 is unique to this record alone. Because why do we need a primary key? Because sometimes last names can duplicate, right? You can have multiple servers, you can have multiple chuas. First names can duplicate as well. There's sometimes a lot of Abigail, sometimes a lot of Andreas in the record books, right? Especially if you have a million records. But the thing about this is that this table can only have one unique ID, one primary key. So do take that in mind, okay? It's called a key field, your primary key. It is unique. So think about this. You as students of the Ateneo are all in Ateneo student database, right? So if you think about it, there's a database in Ateneo that keeps all the student information. That's why they have your names on ISIS. And here we have a checkpoint quiz. What do you think is your primary key in this database, in the Ateneo student database? What is the field that helps the Ateneo database distinguish you as a student? So for example, Fupchua. How do I know that? How do I access your information? What is the primary key of this record in the Ateneo database? Okay, so expect that on to pop out on Moodle. I will move on from these descriptions because we talked about this in the earlier slide already, so let's just move on. Here are database uses. Uses of databases are as follows. Reduce redundancy. So to explain reduced redundancy, databases have strict rules to eliminate redundancy of data. So when data is already injected to your database, you cannot repeat it anymore. This is done through the primary keys of your data as we discussed here. We discussed primary keys here, so this is how you reduce your redundancy. Next are integrity and accuracy, ability to adapt to changes, performance and scalability, and security. I will try to summarize these points in an example. Imagine you are trying to make a class list. Okay, you're trying to make a class list for multiple classes on a spreadsheet like Microsoft Excel. So we're not using databases, okay? We're using spreadsheets. I want you to make a class list. So what you would be typing as your columns, right, are your names, your ID numbers, your year and course, birthdays, and other information individually. And for example, you're enrolled to both MSIS 20 and another class like math, English, or Filipino. Your name is found in all of those class lists, correct? So in those class lists, you typed your name multiple times, you typed your ID numbers multiple times, your year and course multiple times, so on and so forth, thus being redundant. And you do this for all your other classes. You have multiple classes, you may copy paste them, right? But again, it's redundant because your name and file are found on different class lists. So what if, for example, in between the semester or quarter that we have right now, you decide to shift courses? Like you decide, oh, I don't want to be BSMIS anymore. I don't want to be BSLM anymore. I want to be creative writing or something like that. You will have a new course listed down, correct? Now, for all the previous class lists that you have to manually change the courses one by one, correct? Before they were all BSMIS, for example. But because you shifted courses, you have to change now all of them to AB creative writing. So you have to find all of those files that you're enrolled to and change them one by one. And it's a hassle, right? Not only is it already redundant, but then you have to actually do it for all your classes, all your spreadsheets. Um, this is the difference of the data integrity of spreadsheets and databases. All you have to do in the database actually is to just change one entry in the student's table. Like for example, I'm just going to change the course of the student, and all the following class lists courses will follow. I'm sorry that this is sort of difficult to visualize because we are not really working with databases at the moment and I don't have visual examples to show you. I will leave a poll on Moodle if you want a supplementary lesson on what a database looks like and how it works, because it's not really required in the class. But if you want one, I will leave a poll on Moodle to see if you want to have a supplementary lesson on how it works. Just vote either no, sir, I think I already understand how it works, or yes, sure, I want to see what you're talking about. Okay? But with that, let's move on. There are two types of databases, relational and NoSQL. For simplicity of this course, we will not tackle NoSQL databases, and we will just discuss relational database management systems, or RDBMS. Okay, RDBMS, Relational Database Management Systems. Relational databases make use of a table structure, as discussed earlier in this video. So the ones that we were discussing, the records, the fields, the tables, they are relational databases. They make use of tables that have records and fields. The key advantage of relational databases is their ability to link two or more tables together. So yes, you can actually connect multiple tables in databases, in relational databases rather. The connection of tables is done through one of these three architectures: one to many, one to one, and or many to many. Again, one to one to many, and many to many. The one to one relationship is relatively easy to accommodate. For example, each person has only one and only for example, each person has one and only one birth date. Now, if you only have one birthday, there was only one day of the year that you were born. You have your employee table on the left, like in this example, you have your employee table on the left, and you have your birthday table on the right. And you will connect them via one-to-one. An employee, this employee over here, only has one birthday. If you would notice, this is the employee ID, right? It is the primary key of the employee table. So this employee over here only has one birthday, and this employee over here has only one birthday, thus making a one-to-one relationship. Next, the one-to-many relationship between records is a bit more challenging as compared to one-to-one. The example I want to give here is a mother and her children. So just scrap whatever is written here. Okay, so ours is a mother and her children. On one table, actually we can use this, yeah. On one table, you have your mothers, right? For example, the employees are mothers. Uh, and on the other table, you have your dependents or your children. The children can only have one birth mother, right? So these children, these dependents are linked to this employee, but the mother can have many children. So that's a one-to-many relationship. You have one mother that can have many children, but these children can only really have one birth mother. So that's how it works. So for example, Danzen, Lawrence, and Kevin are dependents of only one employee, 650, and Yasuo and Yone are dependents of only one employee, 919. Everything clear? Next up are many-to-many relationships. This is sort of more complex, okay? Um, this is more complicated than one-to-many. An example I want to usually give here are students and the classes that you are enrolled in. Like in classlets, again. Uh, so you, for example, you have your students table and your class table. So for example, these are students, these are classes. A student can be enrolled in multiple classes. As you can notice, right? You are a student, you're enrolled in multiple classes, but the classes can also have multiple students enlisted in them. So yes, this is your many-to-many relationship. Moving on. We have already established that you can link multiple tables in relational databases using one of the three database architectures. But how do you actually really link the tables together? So how you do it is by using the primary keys of the table. Again, the primary key is the unique identifier of a record that cannot be duplicated. So what you do is you take the primary key of table A. For example, this is our table A. This is in table B. Table A is students and registration table is table B. So you take the primary key of the students table, table A, and inject it as a new field in table B in the registration table. As you can see in this slide, we were able to link the students table and the registration table by taking the primary key of the students table, their student ID, and then what we did is we injected it, we put it as a new field in the registration table. So this is our registration table. You could see that student ID is over here, right? We linked them via this. So the registration table's primary key is register number. Okay, this is the primary key of the registration table. Don't get me wrong. Okay, this is the primary key of the registration table, the register's number, and the records hold some of the primary keys of the student's table. So for example, in our registration table, this is the unique identifier. This is student ID, right? We got student Banza, Boy Banza, and this is the class code. And in the registration 2, we got the student Banza again, and we put the class code ADC. And in this registration, we got student code 2553, which is Candid Cruz, and we put the class code as bot101. Okay, so what we were actually doing here, okay, is that this is the new field that we created to connect the student table to the registration table is what we call the foreign key. Okay, so this student ID row over here, which was the primary key of this student table, is what we call a foreign key. Okay, this is foreign key. The foreign key, so the foreign key is, in this case, the student ID field in the registration table, is a primary key from a different table to be able to connect those two tables. Okay, so again, how do we connect tables? We take the primary key of table A and we inject it as the foreign key in table B. Again, take the primary key of table A and inject it as the foreign key of table B, as you can see over here. Okay, next. So what is SQL? How do you retrieve information? SQL, or Structured Query Language, is the language. Remember programming languages. Though SQL is not a programming language, okay, but it is, you know, it uses a syntax. SQL is the language you use to interact with your relational databases. It looks something like this. The structure, right? It follows a specific syntax. Like select star from students. So what is happening here is the keyword is select everything from the students table. That is how it is read. And in the following is you are trying to insert in this next line, you are injecting a new entry into the table via SQL language. Okay, so how you write data in your databases is through, it looks something like this. If you want to insert a new entry, a new record into your table, it looks something like this. Insert into students, ID number, first name, last name, values 1409111, Jacob and Chua. Okay, moving on. So what do you need to consider when you actually build your own database? You need to know the content or what data you will be putting in, who's able to access that data, the physical organization, and the logical structure of your database. This include the relationship of your tables, their architectures, the one-to-many, many-to-many, how are they related, how will it be overall designed. Okay. With that, you have to plan your data model or the logical structure of your database. Okay, here you have to plan your overall data model. What will be your tables, like what will be their titles, what will be recorded in them. Like if, for example, you have your tables, what will be their columns, what will be their rows. Um, how will you connect the relationships among your tables? Okay, so it's designing multiple tables, right? You design multiple tables, you design multiple, in those tables, you have to identify what the columns should be, what will you be recording in them. And after that, you have to also consider how you are going to link one table from the next. Okay, so these are the things to be considered when you are making databases. You also have to take into account how and who will manage your database. um, will your database will your database be scalable for many users and entries? Will you be hiring someone to administer it? The one you will be hiring must know how your database is structured, your DBA, right? You have your database administrator. They must know the primary keys and the foreign keys of each table and the documentation of logs for your databases. These are the things you have to consider when you are making a database for an organization. Okay? So, here is an example of a many-to-many relationship table architecture, as what we have here. And the planning to be able to achieve this is done by using an ERD, or an entity relationship diagram. How you are able to achieve to make a table like this is done through an ERD, an entity relationship diagram. This diagram over here, the ERD, is the overall blueprint of the relationships of your tables. As you can see here, you have your customer table. This is your customer table, right? And these are the features. These are the fields. Sorry, these are the columns that you have for your table. So in your customer table, you have your ID, your first name, your last name, your birth date, your password, your email address, and your fields. Okay? So these are all tables. This is a customer table. This is a purchases table. This is your merchants table, so on and so forth. All right? And in each table, you identify the fields that they have. So the merchants table have their ID, name, merchant type, and passwords. So, and if you would notice, in between the tables, they have lines that join them. Okay, this line is the relationship that these tables have. So, for example, the customer table and company table have a one-to-many relationship. This customer table and company table have a one-to-many relationship. See, as you can see, there is one and many. So those are just diagram rules na. I will not explain them anymore because they're not tackled in this course. But if you want to learn more about them, you can leave a comment. You can leave an email and ask me about, sir, what does these lines mean? But for the simplicity of the course, this won't be included in your in your quizzes, in your home, in your quizzes. These relationship, how you make a diagram, it won't be included. Okay, this is just to show you a view on what a blueprint of a database looks like. Okay, so yeah, I will not get into detail how this works. I will leave it as an ERD, right? The ERD is the blueprint for the relationships of the tables in the database. Again, if you want to learn about it, you can email me or Sir Gabo, and we will gladly explain these to you. So let's move on. Last on this lesson are data centers and data warehouses. Data centers and data warehouses, okay? Do not confuse them with one another because they are extremely different. They are extremely different from one another. A data center is a physical location where you keep your database servers. Okay? So a data center is like a location where you keep your powerful computers. They are climate controlled to prevent your servers from overheating. What they usually do for this are use for this are large shipping containers. You know when in movies when you have like big ships with cargo inside, the metal things, the rectangular ones. They are large shipping containers and there are multiple servers stacked inside. Inside these shipping containers or inside this data center right now are heating, ventilation, and air conditioning or HVAC equipment or units to keep them from overheating. Because you don't want your computers to overheat, right? Because they hold sensitive data. So you want to properly ventilate and cool them so that your data will be protected. Again, to summarize, data centers are physical locations for your database servers, okay, that are in climate controlled buildings. Next up, we have our data warehouses, okay? Data warehouses are not physical locations. Data warehouses, um, they do ETL, okay? They do ETL, extract, transform, and load. Again, they are not physical locations, okay? They are your software. They do extract, transform, and load. ETL. So what a data warehouse does is it collects data from multiple databases. So that's your extraction, right? You are extracting. So here you have your operational data, customer data, inventory, so on and so forth, right? You have lots of data coming from multiple sources. So you are extracting them. Next is you clean up your data, you process it, you transform it. This is where transform comes in. You sanitize your data, you clean it up, you match them with one another, so on and so forth. This is the transformation process. And last is it injects the data into the data warehouse. Right. Sorry, this arrow is upside down. This arrow is upside down. There you go. It should be like that. So once you've extracted all your data from multiple databases, right, and you transform it, you clean it up, then you will load it to your data warehouse. Okay, so what your data warehouse includes is a bunch of data from multiple sources, right, that is sanitized. So the data warehouse is a central data repository containing information drawn from multiple sources that can be used for analysis, intelligence gathering, and strategic planning. The data warehouse, this over here, makes data easily accessible for strategic planning and opens up wealth of opportunities for managers seeking insights about their markets, customers, industry, and more. Because you extract the data from multiple database sources and turn them into information for better decision making, right? You got your data from every other source that you have and you just loaded it into your data warehouse. It often becomes the main source of business intelligence that managers tap to understand their customers' markets and make strategic plans. So, What is data mining? Yeah, what is data mining? Um, Data mining is a tool that involves the automated discovery of patterns and relationships in a data warehouse. It is a software, okay? It is a software, data mining, that analyzes your data for you so that you can immediately draw information from the data you collected. It is able to extract patterns, trends, and rules from data warehouses to predict or score proposed business strategies. So, some form of data mining include forecasting and predictive analysis that help you make better decisions for the upcoming days, weeks, or months. As you can see, all this can be possible with data. It is how you use this data to help in the decision making and strategic process of your organization. Right? You see the value of data over here, right? You get multiple data from many sources, you clean them up, and now you have a data warehouse. So you have this uh, central repository of your important data. And with the data you have in here, you process it. You turn it into valuable information through data mining, searches, queries, whatever information that you need. See, you can have predictive analysis, you can have forecasting, so on and so forth. Again, this as you can see that this is all possible with data. It is how you use this data to help in the decision making and strategic process of your organization. And you as MIS are the ones who should be recommending to organizations on how to leverage the data that they have or are collecting. Okay? And with we will end with this slide uh, with business intelligence or BI. Okay, so to give you a preview of what BI is an umbrella term that involves gathering enough of the right information in a timely manner and in a usable form. Okay, because as MIS, you want to give the right information to the right people at the right moment. So again, BI is an umbrella term that involves gathering enough of the right information in a timely manner and in a usable form, followed by analyzing it to have a positive impact on business strategy, tactics, or operations. To generalize everything that I said, you are processing your data into useful information. And this is why we study databases, to be able to keep our data in the first place. Because databases store our data, right? And with the thing that stores our data, we are able to process it into valuable information. With that ends Module 2.1. If you have any questions, leave an email for me or Sir Gabo, and we would happily answer your questions. Thank you so much and see you on the next video.